Hello friends, welcome to Truth of Physics. Today in this video I will discuss how can we use a transistor as a current source. What is that? Let us understand this circuit. This is a current source circuit. How this circuit is operating, let's analyze this circuit. Okay, now you can see this very easy simple circuit. Here this is a common emitter configuration, right, of this transistor, and this transistor is a NPN transistor. This terminal is N, this is P, the base is P, and the collector is at N. That means this is what a PN junction. Now we know that for a PN junction the forward diode drop is 0.7 volt. That means if we give here the 5 volt DC supply, then the voltage at this point will be this minus 0.7 volt. That means 4.3 volt, right? Now this is 220 ohm resistance, this is 100 resistance, and this is a variable pot. Pot means a variable resistor. This resistor's maximum variable resistor's maximum resistance is 470 ohm, suppose. So it can vary from 0 to 470 ohm. Now what will the current in this circuit? The current in this circuit will be 4.3 volt divided by this resistance. So what we'll get, if you calculate, then the current IE, this current is what? This is E terminal, that means this is PN transistor's E. So this is emitter current IE, which will be equals to 20 milliampere. Now we know for a transistor, a common emitter configuration, IE is almost equal to the IC current. How? Let us understand that also. IE, we know that for a transistor I is equals to IB plus IC. Now, and we know IC is equals to beta times IB, where beta is typically equals to 200. The value of beta is typically 200 for practical cases. Now so I will be what? IC into 1 by beta plus 1. Now this quantity 1 by beta is very much small, so it is almost, I is almost equals to IC. So IE, this current is almost equal to IC, so the same amount of current IC will appear here. So as we vary the, if we vary the resistance 470 ohm from 0 to 470, then also as this current is not changing, I is not changing, so according to your theory the IC should not change, and that will happen practically also, almost that will happen. So this is the fundamental concept of how you can construct a constant current source. So if you measure the current along this wire, then you can easily see in the multimeter that the current is showing a constant current, almost constant current. Now this is the fundamental thing. Now there are some subtle concepts behind that. What are the concepts? The number one is the compliance limit of this circuit. What is that? Suppose this is 20 milliampere, current is following in this circuit, I is 20 milliampere. That means if we maximize this resistance, variable resistance at 470 ohm, then what happens? Then the drop across this resistance will be what? This current, as I is equals to IC, so the current, the voltage drop across any resistance can be calculated as V equals to IR. So I into R, that means this resistance 100 into 20, that means 2 volt drop will appear here. So the 2 volt drop is appearing here across this resistance. Across this resistance what will happen? Across this resistance you will get 470 into 20 milliampere, that means 9.4 volt. 9.4 volt will drop across 470 ohm resistance. Then what will the total drop? The total drop will be 11.4 volt. So the 11.4 volt drop will appear across these two resistors. So what amount of voltage is left? We have given 15 volt DC supply and 14.4 volt is dropped across these two resistors. So the left amount is 15 minus this thing, that means about 3.6 volt. So this voltage will appear here at this point, and this point is what? VC. So the VC is equals to 3.6 volt. Now we know for a transistor to work in the active region, the VCE must be greater than 0.2 volt. This is the fundamental concept of transistor. Now VC is what? VC means VC minus VE, the voltage difference. VC minus VE should be greater than 0.2 volt. Now this voltage is appearing, VC is appearing here 3.6 volt, and we know that VE is appearing here 4.3 volt. That means the VC minus VE is not here greater than 0.2 volt. Even it is now less than 0 volt actually. So that will not that is contradictory, right? So that will not work. Actually it is, if it's we maximize this resistance, then this will not act as a proper constant current source. Then the current will not be constant here in this way. Why? Because we are outside the compliance limit of this thing. The compliance limit is when we fix this voltage. Okay, at least the VCE voltage should be 0.2 volt, and that we called when the VC is equals to, when it is greater than 0.2 volt VCE, then we call that the transistor is working in active region, and when it is equal, then we call that it is working in saturation region. Now when we vary the resistor, when we increase the resistance from 0 to, suppose the resistance first was 100 ohm, then we are increasing it, then what is happening here, the drop across this voltage is increasing. That means what should happen, the current I is equals to what, V equals to IR, means I equals to V by R, means 15 divided by the sum of these resistances, right? So theoretically you can understand that whenever the resistance will the value of the resistor is increase, then the I should drop, the IC should drop, but it will not happen because IE is equals to IC. In the active region it should happen. So the transistor will do what? The transistor will drop this voltage VCE. Then what happens? Because due to the increase in resistor, the IC should drop. So this voltage VC will drop down. Then what happens? If this voltage drop down, then the difference of this, the IC will be what? The difference of these two voltages, 15 minus this VC divided by the resistance. Now this is what dropping down. That means IC will again increase. So this will compensate this decrease in IC due to the increase in this resistor. So thus this circuit is working. So in this limit, the circuit will work as a constant current source. Thus this circuit is maintaining the constant current in this way. But after that, when you increase this at a certain limit, after a certain limit it will go to the saturation region. That means it will drop down and drop down, and once it will come to 4.5 volt. Now after this it will not drop down anymore. The VC cannot drop down anymore, because then the VC will be less than VE, and that cannot happen. So when this will arrive, this case will arrive, the VC will become 4.5 volt, then this will be VC equals to 0.2 volt, and this will be in saturation region. So then what happens, it will act as a constant voltage source. How voltage source? Constant voltage source, because then whenever you increase, suppose this case will appear at 300 ohm, suppose, then what happens, then after you increase this, when you increase this resistance, then the current will decrease down, the current here will decrease to maintain the VC constant. Then this voltage will be constant, but the current will vary, the current will decrease due to the increase in the resistance. So then it will not work as a constant current source. Now another complexity in this circuit is, practically when you do this circuit, actually when you are in compliance limit, and this limit is called the compliance limit. Okay, practically when you are in this compliance limit, that means you are in the active region, then also the current, you can see using multimeter that the current here is varying a little bit. Remind, you are in active region, so the voltage Vc will drop down and the current should remain constant according to our theory, but practically it will not happen because of the early effect. What is happening here actually? Then in the active region this voltage will change, right? We have discussed that Vc will change to make this current constant. So as Vc will change, then the Vc minus Ve, the V is fixed but Vc is changing, so the difference will change. That means which is equals to Vc, this will change, and as this will change, we know from early effect, if Vc change, then the beta and also the VBE, BE means Vb minus Ve will change. As this change, this will change. It is given by early effect. Now Vb is constant 5 volt, then Ve must be changed. So Ve is changing when it is in active region also. So as Ve will change, that means this point voltage will change. So that will be so the current in this way IE will change, and as IV will change, IE was equals to IC, so IC will also change a little amount. So this is the reason why in the compliance limit also, whenever you change the resistance, then you will not get a fully constant current here, but you will get a little bit changing current in the IC. So I hope that you have understood that how this circuit, constant current source, is working. Now to recover this circuit, to overcome this type of faults, we can modify this circuit, we can improve this circuit, which I will discuss in my upcoming videos. To get the notifications of my upcoming videos, subscribe this channel and take care of yourself. Thanks for watching.